Hello and welcome to episode 22 of Dominique Prinet's course on celestial navigation. My name is John Pinto. I'm an amateur astronomer and mathematician, and I'll be presenting Dominique's course to you. Today's episode is all about finding the sun's height, HC, with the interpolation for declination minutes. So it's a follow-on episode to our previous one. This course is based on Dominique's book, Celestial Navigation, along with the accompanying exercise manual. You can find out more about how to order these books at marinenavigationbooks.com. There you'll also be able to download this slide deck that we're presenting this course from, and also a PDF of the exercise manual. So today we're going to interpolate HC for the exact declination, which means taking into account the minutes of declination. In our previous episode, we just used whole number degrees of declination, but now we'll get into what will be more common, where the declination will have some minutes added to it. And the way we do that is when we look into the site reduction table, and you look up your LHA, your latitude, and your declination for the degrees of declination, and you follow it down to the row and the column, you're going to see something called the difference D in HC from 1 degree of declination to the next. That D stands for difference for 60 minutes of declination. And that's going to basically help us with our interpolation. And you'll see that D in the center line of each column for the site reduction tables. And when we look at that in a moment, you'll see that. Then what we do is we interpolate HC using this D value for the minutes of declination using table 5, which you can find in the exercise manual appendix, page A3-16. In the actual site reduction tables, you'll find table 5 somewhere in the back of the site reduction table book. So let's take a quick example here. So let's assume our boat is at latitude 48 degrees north. The sun's declination is 15 degrees 14 minutes south. So at 48 degrees north, sun being 15 degrees south, we're in some kind of winter season for someone in that latitude. The latitudes are contrary, so boat's at north, sun's at south, so it's a contrary latitude. And when you have a contrary latitude, any increase in declination, so if the declination goes up from 15 to 16 to 17, etc., you know that the sun is getting further and further away from your boat. Because if you remember, declination is basically like latitude. So as you're going further south in latitude, you're getting farther away from your boat. So that's going to lower the height of the sun above your horizon. It's just something to think about as you're doing these tables. You should have some sense of what's really happening in reality, so that when you do look at things up in your table, it sort of makes sense to you. Your LHA is 53 degrees, again, for this example. So let's go into the site reduction table, and we find 15 degrees, which was our whole degrees of whole degrees of declination. So we see 15 degrees, and at our LHA, and I'm assuming this table is for the correct latitude, we see that the HC would be 11 degrees and 20 minutes. And if we had gone all the way up to 16 degrees declination, the HC, as we can see, went down to 10 degrees 30 minutes, which is a difference of 50 minutes. And the site reduction tables will put these minus signs here if it's decreasing. So, and it may not be on the exact line you're on, it may be above it or below it, but somewhere you'll see the minus sign to remind you that the declination is going down for each 60 minutes of declination. So for every 60 minutes of declination, it's going down 50 minutes in HC. All right, let's see how we use that. So this is table 5, which is basically a big interpolation table. Dominique likes to call it the rainbow table because it kind of looks like a rainbow when you look at it from far away, because it's a symmetrical table. So you can use this table either going from here to here or from here to there. doesn't really matter. You'll get the same answer. So let's do that interpolation. So what we saw was that the D was minus 50. So you look up 50. The declination minutes was 14. So you look up 14. And where the two cross, boom, you have to adjust your HC by 12 minutes. Now, since it was minus 50, that means we have to subtract the 12 minutes from the HC we pulled out of the table to get 11 degrees, 8 minutes. So here's our example answer: 48 degrees north, 15 degrees, 14 minutes south, LHA 53 degrees. You take your HC, which we pulled out at 15 degrees, which was 11 degrees, 20 minutes. And from our interpolation table, we saw we had to subtract 12 minutes, which gives us our final answer is 11 degrees, 8 minutes. You have an exercise to do for homework. Again, in the exercise book, it's exercise number 17. And you're going to do, sort of what we did in the last episode, but this time you're going to use that interpolation table to get the exact HC for the exact declination. So again, this is fairly self-explanatory. You're given all the data that you need, your assumed latitude, declination of the sun. You have to tell whether it's same or contrary. We give you the LHA, and you will go into the site reduction tables, publication number 249, either if you already own those, or you can look them up in the back of the exercise manual. And you'll pull out the HC from the table. You'll look up that D value, right, that you'll find in the table in that column, and you're going to mark whether it's a plus or a minus and how much, okay? Then you're going to go into table 5, which is that interpolation table, and you're going to pull out whether you're plus or minusing the interpolated value that you get out of the table. And then you get your total HC, which is basically the sum of number 1 and number 3 to give you your final HC. Now, just a reminder, practice makes perfect. You pull out your Z angle as well, and you could put in your 180 or 360 if you need it because of the formulas down here, and calculate your ZN. All right, so that gives you basically from beginning to end, how do you go from your assumed latitude, your local hour angle, and declination to finally pulling out the final HC and the final ZN. Next week, we're going to talk about the Mark St. Hilaire method, which is the method we're using to do our celestial navigation. There are others, but this is the one that's probably the most common, most popular, and probably the easiest to use. So we'll cover that next week, and we'll see you then.